there might need to be some setup that you need to do in order to get this to work, depending on the ID you're using. If you're an IntelliJ, it will ask you to find the cargo.toml file, which should be simple. I wish I hadn't set this up beforehand so I can do this now. It's right here. This is the one that we'll be using. The way this library is structured, it's a bit unusual for Rust libraries to have multiple binaries. So we have the src file. And again, in the same folder that the src file exists, we have the cargo.toml and the cargo.lock. And then we have all our libraries, which is the code in common between all of our binaries. And then we have a bin folder, which has each binary. And then that when we compile it, it outputs it into target release or target debug, depending on which one you choose. For now, you can really just ignore that and just do something like, if you're an IntelliJ, Control-Shift F10, and that should run. So it doesn't error out. Again, that did not error out. Or you can hit this green button over here to get things to run. Just some housekeeping. All right, so for our first task, let us go to make a Lisp. And we're going to follow along with this. I know that this is not necessarily the greatest idea to follow along, to have a tutorial on top of a tutorial, but this is an amazing tutorial, and it also has self-hosting capabilities. I am not writing a self-hosting Lisp by myself. So here we go. Create the step 0 REPL. Yes, we already created the file. And then we're going to add 4 functions, read, eval, print, and rep. And these functions at this point are not going to do anything, but later on these are going to be the foundation of our REPL. Let me first turn off Copilot. Fn read, and this will take in text, which is a type string, and we'll go to a string. And for now, we will not make it do anything. We'll just say to do. Actually, we don't want to make it do it yet. We just want to return the text. So in most languages, this would just be return text. However, in Rust, which is an expression-based language, which we will talk about in more detail later on, you can just write this. And this would just mean return text, because this is the last line of the function. It's not really the last line that it will return, but for now that's a simplified enough explanation for what will be returned that we can deal with it. For now, I'll just leave this as return text so everybody can follow along without getting a headache. Then fn, what comes after read, we have eval, and this will take in, I don't know, let's call it text2, string, then return text. Yes, I recognize this is not actually doing anything at this point. So fn print, let's hope that's not a used thing. Okay, that actually works. Text, string, and this goes to a string. Return text. And after print, we have rep, fn rep, which takes in text, which is of type string, and goes to string. And this, which is going to be the foundation of our REPL, calls read on text, and then it calls eval on the output of read, and then it calls print on the output of eval. And to make this a bit easier to read, we will just do let text, let t equals read text. Okay, don't forget to close off the line. I know it's annoying, but later on you'll learn to appreciate the fact that you need to close every line. And let t equals read text, not retext. You know what? Let's call this text. Text. This should be eval text. Let text equal print text, and then we just return text. So to be clear, what's happening here is, while it might seem that we are mutating text or reassigning text, that's not what's actually happening here, even though it's functionally the same thing in this scenario, but in other scenarios it will be very different, because text is not mutable. I have not made it mutable. It is not changeable. It's an immutable object that'll be the same from now until eternity. However, what I have done is, when I call the let syntax, I've created a new variable, which I'm calling text, which happens to be the same name as a different variable, and assigning it to something. This variable is also immutable. And then I'm calling text, I'm calling let again, and creating a new variable, also happening to be called text, and calling and assigning it to eval of the previous variable that was called text. If you looked into memory, I mean, it wouldn't be like this, but if you look into memory, you would see 4 different variables here. Each, I mean, even though we're calling them by text, I presume in memory these are not called by the actual variable name and have some sort of weird assignment text associated with it. But this is just helpful syntax for us to see, because we're allowed to call variables the same name. And then later on, whenever we refer to a variable that has 2 names associated with it, what it means in the context is, get me the last variable that we assigned. Now, why would this? How would this actually be different from a mutable variable? So imagine if we had a while loop. So let text, or let t equal hello dot the string. We'll cover why you need to add that dot to string stuff there. So then we're going to say wall, not wall, we'll do a for in, what's the range syntax? For I 0.10. Did I get the range syntax very wrong? Let's just put this at the end so it doesn't get mad at me. For I in 0.10, let t equals hello world. So now, while this variable t and this variable t both have the same name, because they aren't the same variable, when I call t over here, let's say I say return t, this value t has the value of hello, not the value of hello world. Because all I did in the for loop is I created a new variable t and assigned it the value hello world. However, this variable t was never changed. Now, if I hypothetically wanted to change t, I'd have to first make t a mutable variable by giving it the mute variable. And then instead of saying let t over here, I would have to get rid of the let. And the reason why this is not working is because if you can hover over mismatch types, expected string found at stir. And yes, Rust has a very annoying thing where there are 2 different kinds of strings. And the default string when you write something out is a stir, even though stirs are far more annoying than regular strings. So in this scenario, because we're assigning it to something that's a string, not a stir, you gotta do a string. I mean, we did this up here as well. So yes, we've now reassigned t, this variable t, to be hello world. Now when I call return t, I'll be returning hello world over here. So again, going back to here, as you can see, these are all not the same variable. Okay, now we did that. So we need a main loop that repeatedly prints a prompt. Basically, this is now where we get the input from the user and then take that input and send it to our read eval print loop, our REPL, so to speak. So we're going to need a wall. So what condition are we going to use for our wall? We can leave that for now. And all true. Yes, this is bad Rust. For now, we will turn this into a loop if we can. So the first thing we need to do is print to the standard output. Print. Make sure not to use your print function, even though they have similar names. This is a macro, not a function, as you can tell by the very stern exclamation point. We will print. What are you supposed to print? User star and then space, and then again you gotta end the line. Then we need to get the user information. This involves a function, I forget its name, and there's no shame in, there's no need to memorize every single function in the standard library. Let's Google get user input rest or read line. This is just, so we need std.io. You know what? ChatGPT. Sorry, this has been my go-to searching. That's not helpful. ChatGPT. It is very annoying. It is surprisingly annoying. I don't know why it's not working. Okay. So the first thing we're going to need to get the input is we're going to do this outside of the loop. Here, you'll see why. We need a string. Let buffer. This is just the thing that my C teacher taught us to use. It's just a string. Dot the string. Now we have to call what function is it? We need our standard input. Let standard input equal std.io. Is that what it is? No, io.stdin. So this is the standard input. This is what you connect with when you type something into the terminal. It's the standard input. So this is, I mean, it's not really the standard input, but it's conceptually think of it just as the standard input. Now we have to standard input dot, let's see if you can find the function name, dot read line. Now, again, this is not how it's normally done in Rust. I don't know why readline is such an annoying function to use. Like, you have to give it your buffer, your string, and now this needs to be, as you can see, it's giving us error message. Use of moved value. Or that's not a very helpful error message. Expected at mute string found string. So we're going to make this a mutable buffer because the way this function is working is that the readline function is taking in a reference if anybody has difficulty understanding what a reference is, I can spend time explaining it. I'm just going to assume that this is standard for most people. This function takes in a reference to our string, and then mutates our string to contain the contents of what was written in the terminal. So we need this to be a mutable string because we're mutating it. And over here, it still doesn't help. This is a buffer. So we found a string, but we need it to be a so even if we do mute, you still need to do mute buffer. This still doesn't help. Found string. So we need it to be at mute string. So this is not a reference. This is a regular string. This is an own string. Now over here, this function is taking a reference to that string in order to mutate it. Because if it took ownership of the string, then we would never be able to access it again. Because the function owns the string, and this variable would contain no value, which is not what we want. So we got to send it a reference. If we didn't do that, just let me show you how awesome REST is. Let's try that again. Expected at mute string found struct string help. Consider mutably borrowing here at mute buffer. So anytime you get stuck in Rust, you just compile the program and let the compiler tell you exactly how to fix it. This is exactly how I learned references and ownership and stuff like that. You just follow the cheese. Now this isn't done. This is gonna do annoying stuff. So while true, standard.read line. Now all we're gonna do for now is we're gonna call rep on it. Rep buffer. What's the issue now? So wait, let's first do that. Use of moved value. I'm confused. Use a semicolon where? Oh, in previous, I get that's idiotic of me. So because because we're calling rep buffer over here, and rep takes ownership of buffer, then this is now moved. And then when I call read line on it, buffer contains no value. So we can move this in here. I think that's just simply the best way to do it. Then, by the way, this is just to make it easier on understanding. You're really supposed to do, for pure efficiency's sake, it should be string ... new, but I don't want anybody to be confused for now, so we're just going to take a regular string, and then all you do is call to string on it to turn it into a string. This is I mean, I don't know if this is actually simpler. Actually, well, good. This is probably simpler. We're going to call it equals stir string ... new. So what are these thingies? Or I should have spoken about this here. What are these two ... dots? So in most languages, when you call a static function, you call it the same way you call a regular function. So in Java, if you had string, it would be string ... new. It actually wouldn't be like that because it's a constructor function, so you need to call the thing. But let's say in the math, it would be math.squares, and you do this, which is identical. It uses the same dot notation as if we had a value of x, which was an integer dot squared. Y. In Rust, if you're calling a method on a value, you use a single dot. If you're calling a method on a module, not a method on a module, if you're calling a static method, static is the wrong word for it, but that's the Java word. If you're calling a method from a module and you're specifying which module it's from, you call it using this notation. So this means go to the module string, not really a module, but think of it as a module, and call new on it. Again, this is very similar to Python. Anytime you're calling any sort of variable in Python, any sort of you import anything, and then with unless you specify to use that as a default function, you're going to be calling it with something like PyCharm, not PyCharm, um, Pygame dot game dot screen. So what this means in Python is just go to the module Pygame, go to the module game, go to the module screen. And in Rust, this would be this monstrosity. So we're getting a new string from a buffer. The reason why we are doing it like this is my assumption is it's a lot fast, not a lot faster. It is faster than the thing giving it an empty string and turning it into a string. You wouldn't really notice it. Okay, so we call rep buffer. Let's result. Let result equals rep buffer, and then we will print. We will print. Make sure again that you're calling a macro. We're not going to print. We're going to print len. And if anybody, the difference between print is print doesn't add a new line after it, and println does return a new line after it. And we will call it on result. And then we will run it. Pray to God. Okay, and we forgot something annoyingly. Yes, you need to format every string you do in Rust. Why did that finish? I think I'm going crazy. Wall true. That should not have finished. It's still running. Oh, okay, we gotta flush this. I don't remember how to flush. Ah! Not very helpful. Flush. Wrestling. Okay, yeah, that's what we needed. Oh, we can just call flush, I think. Can we? Oh no, we need std output. Where is flush? This is... I wish I had ChatGPT working. Because it just... I just need to get the std out, but how do I get the std out? Oh, we can just call std out and that gives me the std out. Okay, flush. Flush, okay. I'll explain what's happening once I get this to work. Okay, that worked. Hello world. Why am I getting an extra new line? Shouldn't be getting an extra new line over there. Maybe this should just be a print. Why would that just be a print? Oh, unless result has a new line added to it. Let's try. Okay, so why do we need to flush things? I mean, in a lot of languages you need to do this because a lot of terminals have something called buffering, which means is that you send them output such as a string, and they decide whether to print it right away or not. Why do they do this? Because sometimes you're sending them one letter at a time, and then you don't want your terminal to be printing one letter at a time. I guess first, I'm not exactly sure why you wouldn't want to do that, but apparently we as a society have decided that this is not how terminals are supposed to work. So it waits until you give it enough input. Now, the thing that makes it decide to print is almost always a new line. This is why you don't usually know about this, because you usually end up printing a new line, so it prints right away. However, over here, we called print and did not give it a new line. So we gotta flush it, which just means we tell the terminal to print whatever it has in its buffer right away, so we can do stuff with it. This might be specific to the terminal I am using, because it's not even really a terminal, because I've seen times where it prints it right away and sometimes where it doesn't. Actually, let me even test it now and see whether it works this time around. Yeah, it does. And see what happens here. The second I call D, I give it D, it it flushes it because now it's gotten a new line, but it flushes it out of, it does some annoying stuff with it. Um, I'm curious if, yeah, well, I'm too lazy to figure that part out. So we gotta add the flush. It's annoying. Like you shouldn't have to, in my opinion. This should just be print to just flush it right away. All right, so we have, I believe, a working prototype. Let's try again, just one more time. Hello world. Nice. I'm not sure if we're supposed to get a new line at the end of this. We might want to strip that later. But for now, that should be fine. Okay, what else do we have to do with the first step of make a Lisp? So the only other thing left we have to do with this is add full line editing and command history support. I will not be doing that, or at least not today. There should be a default Rust library for that, but for now I'm just dealing with the standard library, so we can all get a handle on it. So I won't focus on that. There's actually a Rust wrapper around line noise, which we will probably end up using. Add line editing interface code. Okay, so this is the first step. We do want to make sure that it works, so we're gonna let's push it. Push. Finished. Step 0. Oh, I forgot to say, this does not work on Windows. You cannot use, I know Rust works on Windows. The Make a List build system does not work on Windows. That is very annoying. I don't know how build systems work. I wish I did, but I don't. And I can't get them to work on Windows. If somebody does get it to work on Windows, please, for the love of God, show me how, because my current setup is very much not optimal. I am not going to code on, we're going to work on Linux. I don't like using Linux, especially not if I'm doing any sort of recording. And I like my IntelliJ situation set up, so I'm not going to be using any sort of remote server. So what I'm going to do, I know this is very annoying. I'm going to push, I'm going to commit it. We're going to push it, log in, and I hope that worked. Then I'm going to go to here and go to my code space. So this works. Okay, that's a lot slower than than I expected to do. What I'm gonna do is I'm just gonna be using code spaces as just to run the thing. I could use WSL. I've had annoying experiences with WSL. But if this becomes too annoying, I will use it no matter how much I hate it. Okay, it's loading. That's good. Where's our terminal? I gotta pull. This better work. Pull. And simulator. And then where's our terminal? No terminal. 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 And then we will run it. Well, we passed all the tests, so that's good. Okay, we're getting a bunch of warnings, so we're gonna go back to our slides to fix them. And let's get rid of this, and let's run it again just to get the warnings. Okay, so first, error, no infinite loops with loop. This is the equivalent code. Not exactly sure why this is so important, but that annoying IntelliJ stuff. Now, what's our second error? Unused result that must be used. Okay, I am just gonna... This is error handling. I'm not explaining it now. It's a lot more complicated than this, and using expect as a way to explain error handling is a terrible idea, so I won't be doing it. So we're just doing that. But expect equal this message, I don't know, didn't flush properly. I promise you, I will explain error handling. This is just not the right way to explain it. Then this can also fail. So dot expect. This is just, we don't have, this is a warning. Rest wants us to do this because it wants us to handle errors. We're not handling errors. We're just crashing them. It's a difference. Didn't get the line properly. Okay, now we will... am I still recording? Yeah, I am. Just making sure. We will... Wait, any other warnings? Stop and rerun. Okay, done. Now, the one thing we have left to test, we are going to crash it with doing Control-D. And that happened. Why did that happen? Because we closed the terminal. Now, for some reason, readline is not erroring out. Because I'm gonna... I'm getting kind of tired. I will explain this next time. Sorry if this is not... If equals 0 break. That should work. Okay, that worked. I don't know why there's an extra line over here. That's annoying. I don't like extra lines. But, okay, I'll do my best to explain a bit. Readline returns a value. It's basically a value that tells us how did the function go, what happened inside our function. So it returns a value that's either error or int. So when readline return hits EOF, which is short form for end of file. So if EOF, it equals 0. Readline returns 0. Goes to 0. If it crashes, if crash or does something weird that it doesn't really know what to do, it returns error. So now, what does expect do? I'm going to show you the signature for expect, not the actual signature. So expect takes a value, which is int, which is an int, or error. And it returns int. And the code looks something like this. If value is error, crash the program. Otherwise, return int. What this is basically saying is expect takes in a value that can be an error or an integer. And then expect says, okay, if this is an error, I'm just going to crash the whole program because I don't give a damn. But if it's an integer, it returns an integer. So therefore, now I can be like, okay, now I have an integer. And now I'm going to check whether it's 0 because 0 denotes end the file. Why 0 denotes end the file? I don't know. It's likely a leftover or interop with C because we have to do that sometimes. And apparently doing it with the terminal is when we have it at most annoying. This should really just be an enum. It isn't. So we have to match it against 0. So we're basically saying we call readline, we find the value to buffer. And this function gives us an error, earn it. So now we go, okay, if it's an error, crash the program. Otherwise, give me an integer value that tells me what happened in your function. If the integer is 0, break out of the while loop. And that's why when we do control D, it works. By the way, for other terminals, you might not need to add the flush thing and the checking for the 0 value, because some terminals will automatically send an error message when you try reading from them when they don't exist, when they've been closed. That's my assumption. I haven't tested this out on another terminal, but again, you might not need to add this check. And again, even if you fully don't understand it, I promise I will explain error handling at a later date. This is not the greatest place to explain error handling for a bunch of reasons. And error handling in Rust is different. It's hard to understand. So you don't expect to get it on your first try. This is just, again, think of it as boilerplate. You have to add. And I believe, let's just get rid of this. What else do I have to do for this time? Yeah, I think that's it for the first recording. I am gonna just push it and push, and that's it. Now, for some no, not maintenance, that's the wrong word, but just a discussion about this project. Sorry again for the terrible mic. And again, this is my first time doing any sort of recording like this, so I expect it to be rough for a while. If you feel like I'm going too slow, I can go faster. If you feel like I'm going too fast, I can go slower. I'm not exactly sure at what level of Rust programming everyone's at. If you're all genius programmers and I'm explaining something extremely stupid, please tell me. I am not some sort of expert, so I hope I can have an answer for everything and good explanation. I hope to do this as a stream in the future so people can ask questions live. For some reason, it takes 24 hours for YouTube to allow you to stream once you first decide to stream. I don't know why that's a thing, but it is. This is why I'm doing a recording for the first time. I will not be doing any editing, so there's no advantage to the recording. So I do prefer to do it live, as I enjoy company while coding. And obviously, it would help if somebody doesn't understand something that I can focus on it. So yeah, that's that. Thank you for your time.